What lies outside the universe? Well, that question itself is already wrong. Because the universe has no outside. Outside requires a boundary, and our universe might not have one at all. The part we can see has a radius of 93 billion light years, but the real universe could be 1023 times larger, or even infinite, and we are forever trapped inside this 93 billion light year sphere, not because of walls, but because light is slow, only 300,000 kilometers per second. The universe has expanded so fast that light from distant regions hasn't had time to reach us, and the numbers get crazier. The universe expands at 70 km per second per megaparsec. A galaxy 14 billion light years away is already receding faster than light itself. Every second, enough new space appears to fit 1,000 solar systems, and we have no idea what's being created out there. So scientists propose three possibilities. 1. A flat, infinite universe, like an endless sheet of paper, no edge, no outside. 2. A closed universe, a four-dimensional sphere. Walk straight forever, and you return to where you started. A concept our three-dimensional brains cannot picture. 3. An open universe, shaped like a cosmic saddle. Infinite, but curved in a strange, negative way. And then there's the craziest idea, the multiverse. Our universe might be just one bubble, among 500 others, each with different physics, different light speeds, different laws. These bubbles float in something called superspace. But then, what is outside that? And the paradox repeats forever. So what lies outside the universe? Maybe nothing. Maybe the question itself has no meaning. It's like asking, what is north of the North Pole? To understand why, imagine a tiny ant living on the surface of a balloon. Its entire world has only two dimensions, length and width. Tell that ant there is something outside the surface, and it has no way to comprehend it, because height doesn't exist in its reality. We are that ant, trapped in 3 dimensions of space and 1 dimension of time. Physicists talk about 4-dimensional hyperspheres, but we can't visualize them. We can only describe them with math, even more mind-bending. Time itself is part of the universe. Roger Penrose showed that time began with the Big Bang. Before time existed, there was no before. Just like there's no direction north once you reach the North Pole. So when we ask what's outside the universe, we're actually asking what space exists beyond all space, which is a logical contradiction. But scientists didn't give up. Instead, they reframed the question, how did the universe become the way it is? The answer begins in the first 1035 seconds after the Big Bang, a moment so brief that blinking your eye is like eternity in comparison. During that instant, the universe underwent cosmic inflation, an exponential expansion so extreme that its volume grew by 1078 times in a fraction of a second, like an atom ballooning to the size of the Milky Way. This expansion didn't move matter, it stretched space itself, so it didn't violate relativity. Just like the ants on a balloon see each other's speed apart, even though none of them are moving on their own. Inflation explains why the cosmic microwave background has almost the same temperature everywhere, 2.725 Kelvin, even between regions 93 billion light years apart that never could have communicated. They were once squeezed together in the same tiny, uniform spot before inflation tore them apart. The energy that drove inflation didn't disappear. It transformed into dark energy, a mysterious force making the universe expand faster and faster. Dark energy makes up 68% of everything that exists, which means one day this acceleration will become unstoppable. Galaxies will be torn apart, stars reaped away from each other, atoms stretched until they disintegrate. This is the Big Rip, or if expansion slows, we face a different ending. Heat death. Stars fade after 100 trillion years. Black holes evaporate after 100 years. And the universe becomes a silent, cold darkness where nothing ever happens again. Yet the biggest mystery remains. Why does our universe have just the right laws for life? If string theory is correct, the universe has 11 dimensions, 7 of them curled up so small, 10的负35次方 meters, that we can't detect them, and the way they curl determines the laws of physics. Leonard Susskind calculated that these extra dimensions can curl in 500 different ways. Each way produces a different universe. Most of them would have no atoms, no stars, no chemistry, no life. So why do we live in the rare universe where everything is just right? Some say it's design. Scientists call it the anthropic principle. Out of countless universes, only a few allow life. And we happen to be in one of them, because only here could we exist to ask the question, like a lottery winner asking, why was it me? There is no deeper reason. If it wasn't you, someone else would be asking. But then comes an even wilder possibility. What if the universe is programmed? Nick Bostrom's simulation hypothesis argues that if advanced civilizations can simulate universes, the number of simulated universes would vastly outnumber the real one, meaning statistically, we're more likely to be inside a simulation than in base reality. Quantum mechanics behaves like rendering. Physics constants resemble code values. The Planck length looks suspiciously like a pixel limit. But even if this is true, it only moves the question one step backward. Who built the world that built our world? And so the paradox continues. So, what lies outside the universe? Maybe nothing, maybe something beyond human understanding, maybe an infinite chain of universes, or maybe a screen we'll never see, like ants on a balloon, or characters inside a video game. We may never touch the world outside our own, but that's not the point. The real meaning lies here. We can ask, we can wonder, we can stand at the edge of our knowledge, and look into the unknown, and that ability to question the limits of existence might be the greatest gift the universe ever gave us.